morning, students. Today we are going to start one of the very important topics of mathematics. This topic is very useful solving higher mathematics. In this video we are starting from the basics of the set theory. Set theory. We discuss three parts: introduction of set, and second, description of set, and third, types of set. Now first we are going to introduction of set. Now definition of set. Definition of set is a set is collection of well defined object. Here student used the word well defined. There are two types. First, well defined, and second, not well defined. Well defined example are: first, the collection of vowels in English alphabets, that is A, E, I, O, U. The 5 elements contain English alphabet vowels A, that is A, E, I, O, U. It is set because it is well defined object. Now we discuss not well defined. The collection of good teacher in a school is not a set. It is a collection. Students, the collection of good teacher in a school is not a set. It is collection because it is not well defined. We clear that. Now second example also clear. Second example, the collection of all natural number is a set because it is well defined. That is हम ये बोल सकते हैं, that is natural number is denoted by capital N is equal to curly bracket open and so on 1 from 1 2 3 4 5 6 and so on. It is a set and not well defined. Second example is the collection of good cricket players is not a set because the goodness of a cricket players is not defined here, so it is not a set. Clear, student? Now first we discuss set theory. There are three parts of in this video: introduction of set, description of set, and types of set. We are first discuss about definition of set, introduction of set. Now Definition is a set is collection of well-defined object. Well-defined, there are two types, well-defined and not well-defined. Here example are well-defined and here example are not well-defined. Clear, student? Now we are going to discuss about description of set. Let description of set. So here we write two form. So here we write two form. First is roster form and second is set builder form. Set builder form. Clear, student? Description of set. There are two form. First roster form and second set builder form. Now first we explain with example roster form. First roster form definition is in this method all the elements of the of a set are written in a row separate by comma and then enclosed with brackets. Students, roster form definition is in this method all the elements of a set are written in a row separate by comma and the enclosed with brackets. For example, a set consisting of element as the number 2, 4, 6, 8. Let we write roster form is set A is equal to curly brackets open and element are 2, 4, 6, 8. 2, 4, 6, 8. That is roster form of given example. Now second we discuss definition with example set filter form. Set filter. Here definition is in this method a set is described by some properly common to all the elements. Set builder form definition is in this method a set is described by some properly comma to all the element. For example B is the set of all even natural number is denoted by x. The B is equal to then B is equal to x such that x is an even natural number curly bracket closed. Here represent this such that. So student, description of set is completed. There are two form, roster form and set filter form. I hope all clear this topic. Now we are going to learning about types of set. types of set. There are many types of set. First, finite set. Second, infinite set. Third, empty set. Fourth, singleton set. Fifth, equal set. Sixth, subset. 7, proper subset. 8, universal set. 9, power set. And 10, disjoint set. Students, there are many types of set. Some types of set here explained with example. First, finite set. Finite set. Finite set definition is a set that has finite number of element is called a finite set. For example, x is equal to a set that has finite number of element is called a finite set. Finite number 1, 2, 3, 4, 5, 6, 7, 8, 9 here represent the set is less than 10, so it is also called a finite set. Clear, student? Now second we definition with example, infinite set. Similar definition, a set that has infinite number of numbers of element is called infinite set. For example, suppose that natural number n is equal to started from 1, 2, 3, 4, 5, 6, 7 and so on. It is also called a infinite set. Third number, empty set. A set is said to be empty set if it has no elements, that is a is equal to no element, curly bracket. We write a is equal to 5. Here 5 denotes the zero elements. Fourth number, singleton set. Singleton set is very easy. A set is said to be singleton set if it has only one element. It means that singleton set which is called only one element containing in this set. So we write a is equal to a. Small a is the element of set A. In this set contain only one element. It is called singleton set. 5 number, equal set, equal set, equal set. Now define with example. Two sets, two sets A and B are equal if and only if every element in A belongs to B and every element in B belongs to A. Clear, student? Equal set. Two sets A and B are equal if and only if every element in A belongs to B and every element in B belongs to A. For example, here let two sets A is equal to 1, 2, 3, 4, 5 and B is equal to 5, 4, 3, 2, 1. Here every element in represent in also contain set B. So set A is equal to B because both set of element are same. So it is called equal set. Next, 6 number, subset. Subset. It is very important types of set. Subset. We define with example. Let A and B be any two sets. A set A is said to be a subset of B if every element of A is also an element of B, that is A subset of B. If small a belongs to capital A, this implies small a belongs to B, that is A subset of B. If small a belongs to capital A, this implies A small a belongs to capital B. Let A and B be any two sets. A set A is said to be subset of B if every element of A is also an element of B. It means that here two set A and B, every element of set A is also an containing set B. Then we can say that A is a subset of V. For example, first let A and B are any two sets. A is equal to 1, 2, 3 element and B is equal to 1, 2, 3, 4, 5. Here A set A, every element is also containing set B 1, 2, 3. Here set A are element 1, 2, 3 also containing set B. So A is a subset of B. It is denoted by subset. And second example. Now second example. Let P and Q are two sets. P is equal to element are 4, 5, 6 and Q is equal to element of 4, 5, 6. Clear, student? So P is a subset of Q and Q is a subset of P. P is a subset of Q and Q is a subset of P. It means that both are equal. Note, Note, this is possible only when P is equal to Q. That is, both set are